because we now have a third member, so we were able to get mid-range data to fill in some of our missing spots in our bar charts and SSOC graphs. Just to give a brief outline, I'm not going to repeat myself too much for all of you, but our whole speed station is based off of the waste management motor-powered aeration system in Chattanooga. Today I'm going to go over our past experiments with steady-state operating curves and the FOPDT modeling of unit step, and the same thing with the frequency response model. Here we have a basic diagram of our system, the motor, 101 gearbox reduction to the mixture that's inside the aerator tank with all the wastewater. A block diagram of our aerator interface and how we go about collecting data from our system. This is an example of one of our ranges, the low range, of a steady-state motor operating output. Took into consideration the obvious steady-state range where the output was fairly evened out. This is our steady-state operating curve for all three of our ranges, with our low range, our mid-range, and our upper range. Because of the behavior of how a motor operates, our system was perfectly linear, and here's an equation you can use to estimate your motor output for different power inputs in our system. Here's another block diagram of how we went about using a unit step response to monitor our aeration motor, and an example of a 10% step in power from a 10% initial going to 20%, and you can see this like brown colored line is our output of our system, with the off green color being the input percentage of power. Here's our FOPDT model of the unit step. You can see in this bright orange, that is the model laid over the original data from the same example. And you can see how close the FOPDT diagram actually is to our output of data. Here's a bar chart of our low, medium, high range in the incorrect order. This is the gain. Sorry, I have a bit of a cold. The RPMs can, in comparison to the step up and step down, gain the highs and low and mid range is fairly close, with the highest deviation being in our high range, obviously, and lowest deviation here in our mid range. It seemed to be the further we got out on our study of our system, the further the variance was in gain. It's the same thing for our dead time. Same sort of behavior where you have your largest variance at your high and low range, and the most similarity in the mid range. And this is for our time constant for the low, medium, high. Wait. Okay. Nope. Sorry. Yes. This one, however, is different. Our time constant, we have the largest change, our variance here in our low range, and our medium and high range, the time constant became, the variance between the step up and step down was much smaller. It seemed to be that the faster the motor got spinning, the less difference there was in the time constants, and when comparing the step up and step down. This is another block diagram of how we went about frequency response. Here's an example of one of our charts with how we calculated our ultimate frequency gain and went over our critical gain. This is another plot of our phase angle, all part of the same example. This is our modeling. Here are these small off-green looking dots is our original data with our model laid over it and with a smooth curve. It was brought out all the way over here for necessity for calculation, but it was fairly close, and there actually are error bars. This one has the largest error right here, you can tell, but there's very little error in our system to be dealt with. In the frequency, you have your low, medium, and high range, and this is the difference in the gains with the error. The gain was, they're fairly close when you actually looked at it. It's only about 1 hertz off at its maximum. Dead time, also very small when you actually take into consideration from your high to your low. Your dead time was increasing on the frequency model. And this is for our time constant, which had the same sort of behavior as the unit step, where the low and the high were very different from the medium or mid-range. Looks like my conclusion slide got deleted, but when comparing the differences from the unit step model to the frequency model, there's some variance in the upper and lower ranges, where the mid-range was very close for unit step up and down and frequency modeling for our gain, dead time, and time constants.